Good morning, you guys. Hope you're doing well on this Monday. What you are going to need for this lecture, this video lecture, is you are going to need a periodic table of elements, and you are going to need your list of polyatomic ions, and the sub should pass that out to you. Okay, so we got to cover a few things before we get to the meat of it. First of all, I'm going to give you some examples of chemical formulas. So, chemical formulas represent the name of chemical compounds. Chemical formulas, the names of chemical compounds. So it's kind of like a shorthand way of writing the name. Instead of having to write out sodium chloride, we can shorten it up with the chemical formula NaCl. So this is an example of a chemical formula. Another example of a chemical formula might be MgSO4, CH4, C6H12O6. These are all examples of chemical formulas. Again, they represent the name of chemical compounds or molecules. A few things about chemical formulas. They have these subscripts, these numbers that are written below the elemental symbol, and that is a subscript, and that tells you how many atoms of this element is present. If there is no subscript that is present, that means there is only one atom present. Okay, so CH4 is methane gas. So if I was looking at CH4 and I wanted to know total number of atoms present in this formula, I'm just going to add them up. I have my pretend one right here, and I have 4 hydrogen atoms, so my total number would be 5. If I was to look at MgSO4, I have 4 oxygen, I have 1 sulfur, and I have 1 magnesium, so my total number of atoms in this chemical formula is going to be 6. NaCl, I have no subscripts, so that means I have 1 chlorine atom and I have 1 sodium atom. So I have a total of 2 atoms in this chemical formula. This guy over here, this guy is glucose. This is what plants produce in photosynthesis. So we have 12 plus 6 is 18 plus 6 is a total of 24 atoms. So what we're going to do today is we are going to take the name of the chemical compound like this, and we are going to convert it to the formula like this. So what we are actually doing today, I'll write it down, we are writing formulas for binary and ternary ionic compounds. Okay, so a few things that you guys need to remember. You need to remember there's 2 types of ions. There are cations, which are positive, and there are anions, which are negative. That's the first thing you remember. Anytime we're dealing with ionic compounds, the cation always is first in the formula, and the anion always comes second. That's the first thing you need to remember. You also need to remember that there are monoatomic ions, and there are polyatomic ions. So monoatomic ions are ions with 1 atom present, and that's it. So for instance, Na1+. Polyatomic ions are groups of atoms, you have a list of them. Right here, there are 10 of them that we're going to use. Okay. So a polyatomic ion is a group of atoms with an overall charge. So for instance, NH4 1+. So in a polyatomic ion, the atoms act as one single whole unit with an overall charge. So this is called ammonium, and there's the 1+ tells me that this whole group of atoms has lost one electron. Okay, same thing that we are doing with the monoatomic ions, but this time it's a group of ions. Let me give you another example of a polyatomic ion, SO4 2-. This guy is called sulfate. He's on your polyatomic ion list. So this group of atoms, the SO4, acts as one single unit. This entire single unit has a charge of -2. So somewhere amongst this group of atoms, okay, 2 electrons were gained to make this congregation of atoms, and that's called sulfate. So when we are talking about ionic compounds, okay, so ionic compounds, let's start over. Ionic compounds are always going to consist of a cation in the front and an anion in the back. So for instance, sodium is a cation and chlorine is an anion. So my formula, NaCl, okay, is for sodium chloride. So all ionic compounds, and that's what we're dealing with today, is we're writing formulas for binary and ternary ionic compounds. Bi means compounds with only 2 elements. Ternary are compounds with 3 or more different elements. So we're going to write formulas like this. And just a reminder, cation is always in the front, anion is always in the back. So we're just going to start with some examples and we're just going to get going. Okay. Let's start my first one with magnesium bromide. Okay. This guy is a binary compound. I have only 2 elements. I have magnesium and I have bromide, which is bromine. Anytime that second element is in an actual compound, the ending is always IDE. So this is actually bromine. So if I want to write the formula for magnesium bromide, first thing I'm going to do is I am going to find the symbol in the periodic table for magnesium, and I'm going to write that down. And then I'm going to find the symbol for bromine, which is on the right-hand side, and I'm going to write that down. I'm not quite done yet. The next thing I'm going to do is I am going to assign oxidation numbers. So the first thing I'm going to do, or I guess this would be the second thing, I'm going to look on my periodic table and I am going to see what group magnesium is in. And magnesium is in group 2, has an oxidation number of +2. So I'm going to write +2 right above Mg. Now I'm going to look over here and I am going to find bromine, and bromine is right here, group 17, and it has an oxidation number of -1. So I'm going to write that right above bromine. So our goal is to have our oxidation numbers equal 0. Right now, if I was to add these two together, I would not get 0. So the idea is I'm going to increase my number of bromine ions to balance out my 1 magnesium ion. So what I need to do is I'm going to add a subscript. Those are the numbers written below the elemental symbols until these two numbers equal 0. So let me show you. I'm going to add a 2 right here. So if I have 2 bromine ions, each with a -1 charge, Okay, 2 times minus 1 turns this into minus 2. So now when I add these two together, they equal 0. So my formula for magnesium bromide is MgBr2. So basically, let me show you what this looks like. We have one magnesium atom, and it has a +2 charge. To balance out that +2 charge, we have to have two bromine ions, each having a -1 charge. So when we add all of these oxidation numbers up, they equal 0. Now, writing a formula like this would be a real pain in the butt. So all we do is, instead of writing the two elemental symbols, we write the subscript right next to it. So my formula for magnesium bromide looks like that. Let's do another one. Let's do calcium chloride. This is what we used in Off to See the Wizard lab. So I'm going to look on my periodic table and find the symbol for calcium. Calcium is Ca. And then I'm going to find the symbol for chlorine, and that's Cl. So now what I'm going to do is I am going to look on my periodic table, and I am going to find calcium and look at the top and see it has an oxidation number of +2. So I'm going to put +2 above the calcium, and I am going to find my chlorine. I'm going to look above it and find that it has a -1 charge. -1. We're in the same situation. If you add these two together, I'm not going to get 0. So I'm going to have to increase my number of chlorine atoms to balance out the one calcium. So I'm going to put a subscript 2 here. 2 times -1 gives me -2. And now when I add them together, they equal 0. Let's look at how we get the sodium chloride formula. So sodium chloride. Okay, so sodium is Na, chlorine is Cl. We're going to go to our periodic table of elements, and I'm going to find sodium, which is in group 1, has an oxidation number of +1. So I'm going to put +1 above sodium, and I'm going to again go to the periodic table. I find chlorine, I look above it, oxidation number is -1, so I'm going to put my -1 right above chlorine, and the two oxidation numbers equal 0, so my final formula is NaCl. So again, these are all ionic compounds. Okay, so let's try some that are just a little bit more difficult. Let's try this one. Gold 3 chloride. Okay, so this guy is a Roman numeral. And if you're not sure what your Roman numerals are, I will give you a rundown of which the Roman numerals are in just a little bit. This Roman numeral actually tells us what gold's oxidation number, okay? That Roman numeral tells us gold has an oxidation number of +3. So if you look at your periodic table, gold is in that section that I told you don't follow the rules. So these elements between groups 3 and 12, okay? Remember I said they don't follow the rules, they kind of play by their own rules. So if you look really closely and if you find gold, you will see two numbers right above it. You will see a 3 and a 1. That means that gold could give away 3 electrons, or it could give away 1, all depending on what chemical compound it's forming. So these guys in here, between groups 3 and 12, we're not able to put the oxidation numbers right above it. We actually have to look at the numbers right above the actual symbols to figure out the oxidation number. Now, all of these guys between groups 3 and 12, they're all metals. So they're always going to have a positive charge to them. So when you get one of those rebel elements that are between groups 3 and 12, the Roman numeral in the name tells us the oxidation number. So we don't even have to look it up on the periodic table because it's actually right there in the name for us. So we're going to do the same thing. I am going to start with my symbol for gold, Au, and I'm going to put my symbol for chloride, which is chlorine, so Cl. This Roman numeral tells us gold has a +3 oxidation number, so I'm going to put +3 above gold. We've used chlorine before, so we know chlorine has a -1 charge. So again, our two oxidation numbers do not equal 0 when I add them together. So I need to add the number of chlorine ions I have. I need to add more chlorine ions. So the -1 turns into a -3. So if I put a subscript 3 right next to the Cl, 3 times -1 turns this into a -3. So now when I add my two oxidation numbers together, it equals 0. So my final formula is AuCl3. Let's try another one. Let's try iron 2 oxide. Okay, so I'm going to look at my periodic table and I'm going to find the symbol for iron, and the symbol for iron is Fe. I'm going to look on the periodic table. I'm going to look for the symbol for the element oxide. Okay, oxide is actually oxygen, so I'm going to put an O right next to it. I'm going to move it down here. Okay, so now I'm going to assign oxidation numbers. That 2 tells me that iron is +2. So I'm going to add 2+ right above iron. And I'm going to find oxygen's oxidation number. This guy's a rule follower. He is in one of the groups that we went ahead and wrote the number above it. So oxygen is -2. So I'm going to put -2. And when I add these two together, okay, it equals 0. So my final formula is FeO. Okay, so far, every single one of these compounds that we've written formulas for, these were binary compounds. I should say binary ionic compounds, okay? Every single one of them. Iron and oxygen, gold and chlorine, sodium and chlorine, calcium and chlorine, magnesium and bromine. Every single one of them, we were just simply dealing with two monoatomic ions. Okay, so this guy is a monoatomic ion, and this guy is a monoatomic ion. It's not always that simple. Okay, we do have ionic compounds that have 3 or more elements in them, and we call those, again, ternary ionic compounds. So in ternary ionic compounds, get some paper. So in ternary ionic compounds, you could have a polyatomic ion, and that could be bonded to a monoatomic ion. That's one scenario. You might have a monoatomic ion, and that's bonded to a polyatomic ion. That's a scenario. You might have a polyatomic ion, and that's bonded to another polyatomic ion. So this is where we're going to use the periodic table and our list of polyatomic ions, the formulas. Okay, so let's go ahead and get started. Let me get a clean sheet of paper here. Okay, let me show you an example here. Let's go with calcium phosphate. Now, a lot of times the polyatomic ions are going to end in ATE, so that's going to tip you off that, hey, it's not an element, it's not on the periodic table, but I need to move to my polyatomic ion chart. Like I said, I gave you a list. Keep that list. I will never make you memorize those 10. You will just have those available to you. So this is how we write the formula for a ternary compound. In this case, we have a monoatomic ion attached to a polyatomic ion. So I'm going to go ahead and write the symbol for calcium, Ca. And I'm going to go to my polyatomic ion list, and I'm going to find the formula for phosphate. So if I look right here, phosphate has a formula of PO4, and it has an oxidation number of -3. So I'm going to write the formula, PO4. Just like I did before, I'm going to assign oxidation numbers. I'm going to look for calcium over here. Calcium has an oxidation number of +2. So I'm going to put +2 above it. Phosphate, not phosphorus, phosphate has an oxidation number of -3. So I'm going to put a -3 above the whole phosphate ion. So again, calcium is one ion and phosphate is another ion. So all of these elements act as a single group. So now we still need to add our subscripts. This one's kind of tough, not too bad, okay? We still need our oxidation numbers to equal 0. And so a common number that I have between those two would be 6. So I want to turn the +2 into +6, and I want to turn my -3 into a -6. So if I put a subscript 3 right here next to calcium, 3 times 2 turns this into +6. Since I need more than one phosphate ion, I'm going to put parentheses around the phosphate, and I'm going to put a subscript 2 on the outside. 2 times 3 gives me -6. So my final formula for calcium phosphate looks like this. Ca3, PO4 in parentheses, subscript 2. Okay, let's look at another one. Let's look at barium acetate. Again, since it ends in ATE, it kind of tips me off that it is a polyatomic ion. So I'm going to find barium. Barium on my periodic table is found in group 2, has an oxidation number of +2. So barium, I'm just going to put the +2 above it. Acetate is going to be on my polyatomic ion list, and it is the first one right here. So the formula is C2H3O2 with a -1 charge. So I am going to write the formula, C2H3O2. And like I said, it's a -1 oxidation number. So I'm going to put it right above the acetate. Again, remember, this acts as a single unit, and this acts as a single unit. So my barium ion has a +2 charge, and my acetate ion has a -1 charge. So again, I need my two oxidation numbers to equal 0 when I add them together. So I have to increase my number of acetate ions. So this is how I'm going to do that. I'm going to put acetate in parentheses, and I'm going to put a subscript 2 on the outside. So 2 times -1 gives me -2. So now my two oxidation numbers equal 0. So my final formula is BaC2H3O2 with a subscript 2 on the outside. Let's look at one more. This is ammonium chlorate. Okay, so ammonium is actually a polyatomic ion. It's sometimes you just kind of have to, search a little on the periodic table and then move to your polyatomic ion list and see what it is. In this case, my first one, ammonium, is a polyatomic ion, and my second ion is a polyatomic ion as well. It ends in ATE. So I'm going to go to my polyatomic ion list, and I am going to find the formula for ammonium. Here's ammonium. The formula is NH4, and it has a +1 oxidation number. So I'm going to write NH4, put +1 above it. And I'm going to find chlorate. Chlorate is at the top of the list. This is ClO3 with a -1 charge or oxidation number. So ClO3, and that's a -1 charge. So this is one ion, and this is another ion. When I add their oxidation numbers up, they equal 0. So my final formula is just NH4Cl O3. And that's it. Let's do one more. Let's look at copper 1 nitrate. Okay. So the first thing I'm going to do is I'm going to find the symbol for copper. So I look on my periodic table, and the symbol for copper is Cu. If you remember, that Roman numeral 1 tells me that copper has a +1 oxidation number. I don't even have to look for it. It's in the name. So I'm going to put +1. Nitrate is the second half, ends in ATE. So I know it's a polyatomic ion. So I'm going to find my list over here, polyatomic ions, and find the formula for nitrate. And that's NO3 with a 1+ charge. So I'm going to write NO3 with a 1+. Oh, sorry. It was a 1-. My bad. So when I add these two oxidation numbers up, I get 0. So my final formula is CuNO3. That's my final formula. Okay, so I have step-by-step instructions on how to do this on my Google Classroom, and I would have expected for you to participate and in your notes write down all of the examples that I did for you guys. Okay, be good for the sub. I hope you guys have a fantastic day. Get your homework done, and I will see you guys tomorrow. Take care.